Hello, everyone. As already said, my name is Gijs Weterings, and I'll be talking to you about transforming your web application into a PWA. I'll show you why and how you can do this. So, my name is Gijs. It's a Dutch name. It's very difficult. If you want to try it, don't worry about messing it up. I've heard every iteration of it. That's my Twitter handle. I'm a web and software developer for 8 years now already. I'm also still a student at TU Delft, just 60 kilometers south from here, where I do computer science. And I'm actually finishing up that master at Argen here in Amsterdam, doing my thesis. I did do an internship at Facebook over the last summer, and after my thesis I will go back there. So that's why that's there. And also, this is my first talk, so hello world. So progressive web apps. You might have heard of the term before. Web apps you may be familiar with. Most of you actually make web apps probably for a living or as a hobby. But the progressive part might be new for you. So I'll show you the requirements for making progressive web apps. I'll show you what a PWA can do and how you can turn your app into a PWA. So the requirements for PWAs, first of all and most important, be a responsible developer. The APIs you get with PWAs are very, very powerful. You'll see a few examples later on. So you really need to be responsible with this power that you're getting. Otherwise, the user will block you out and stop using your app. Another part of this responsibleness is serving your app over HTTPS. If you don't do that still, you really need to. It's really easy, just make sure you do. The biggest reason to do this is also these APIs will not work on HTTP because we need to have a trusted environment to run in. You also have to have a functional baseline app. So the app you're making now without any progressive features, that has to work regardless of having the features or not. The reason for that is not all progressive web app features are supported in all browsers. So make sure you have a baseline app first that works, that does everything you need it to, and then enhance it with your PWA features. Lastly, your app must use a service worker. A service worker you might not be familiar with, so I'll give you a 10-second overview of it. A service worker is an ambassador for your web app. Basically, it sits between your browser, your server, and the user's browser on the browser side, and it governs all the traffic that goes between them. And everything you do, mostly everything you do in PWAs goes through a service worker at some point. To create one, it's really simple. For your first one, you call service worker.register on the navigator variable with your service worker, and as soon as that promise resolves, you get a registration object. There's, however, a very hard part about service workers called the lifecycle. I won't go into it today because it's way too much for just one talk. But if you want to learn it in a really cool way, go to serviceworkies.com. It's a Telltale game made by Dave Geddes. It's awesome because you have a beautiful music, beautiful graphics, and they tell you in very much detail how service workers work, how this lifestyle works, and he's still making new levels for it, so you can return back every now and then and play some new levels. So what can a PWA do? I'm going to talk about 3 features today. The first one is installing to home screen. So like a native app, you can launch your PWA from the home screen after you've installed it. So this makes it possible to essentially have your website be the native app for your user. Also offline and caching. Once you go offline or at a conference with spotty Wi-Fi, you still want to use your PWAs as a user. So you can do a lot of caching and keeping things offline, so even when you're offline, you can run your app. And PWAs also allow you to engage with your users. So this is the example of push notifications, where you can actually send push notifications, again, like a native app, whenever you want. Again, you do have to be responsible for that. So let's start with installing to home screen. As I said, it allows users to quickly navigate to your app. It requires a web app manifest and a service worker. So we'll see a little bit more of the service worker later, but this is how you make your web app manifest. You basically link a JSON file in your web page, and a JSON file contains these properties that basically describe your app. So by giving it a name, some icons, some colors, and some navigation about the scope of your app, you can have a nice little package that your browser can then use to get that icon on your home screen with all the correct information. And even has a beautiful splash screen for you, so it's super cool to try out. You do have to do a bit of JavaScript still to get that prompt actually up. So I'll go back to it real quick. This prompt, you can only show once to your user. If they don't accept it, you can no longer prompt the user to install your app. So it's really important for you to get the correct timing for this prompt. That's why you can take control of this. So you'll get an event before install prompt whenever the browser thinks that the user is ready to potentially install the app. You can catch that event, prevent default for it, and store it for a bit. And you may want to have a button that you control on your own side that then actually triggers the prompt. And here on the prompt call, you can actually then get that prompt on top. With the user choice, you can either get an accepted or a declined. If it's accepted, success, you've installed the app on the user's device, so they can now launch your app from the home screen. So once the user has installed the app, it's also time to have it be available offline, because the user now expects your app to behave like a native app and works even when they're offline. So a good example of how this works with a service worker is to show this. So you have your browser on the right and the internet on the left with your server on it. And usually you start out with doing a request and getting a response back from the server. If you're offline, the request fails and you never get a response. If you install a service worker, like I said, the ambassador of your app, it sits in between this process. So any fetch request that you do from your app ends up in the service worker, and it controls any communication with the internet. This basically means that you get more fine-grained control of what happens, and you can do some interesting stuff with that. For example, when the internet drops out, you can have resources cached. And if you have resources cached, you can still give them back to your browser as if you were online. So this is the simplest way of getting a service worker to listen to a fetch event. This just listens to the fetch event and immediately calls the network to send out the request. And whatever happens on the network will be the response. So this is obviously sort of the default behavior. But because the service worker is just JavaScript, you may want to have this behavior for some of your resources. The resources that you don't want to store offline, you can still just go to the network, whatever happens. If you do want to cache resources offline, you can have a cache with a fallback to the network. So you try the cache first, and if that doesn't work, you can always try the network to see if you can fetch it. So what I do here in the event respond with, you see the caches.open with a v1. That's just a version number for your cache, so you can clean your caches when you need to. And the cache.match basically checks if the request is in the user cache. If it is, the response will succeed, and you'll get a valid promise back. If it doesn't, we fall back to the fetch at the bottom that basically goes to the network and tries to get the resource regardless of the cache. So one more upgrade to this is still while revalidate. This is a use case perfect for profile photos. So if you change your profile photo, it isn't that important to see that right away. You can have the next request have it. What you do want is a super quick app. So still while revalidate does something very similar to the cache would fall back to the network, only it immediately returns the cached version while asynchronously sending out the fetch to the network. Once the fetch to the network returns, the item is put into the cache, and the next time you need it, it's in the cache, and you have the new version. So these are just a few ways of actually doing these network requests and caching on the service worker. There are way more advanced way of doing it, for example, racing both the cache and the network for devices that have super slow disks, for example. And you have to remember that every resource here can be handled in a different way. So you can handle your profile pictures in a different way than the comments. So if you do this, you can build the strategy in your service worker, test it out very well, and basically you have an offline capable app with the resources you need offline are offline, and the resources you don't need are not in your cache. So things to remember for offline and caching: choose those caching strategies wisely. So pick and match strategies, combine them together in your service worker, and have a good strategy for that. And clean your caches. You don't want to cache all the blog posts of your blog offline for each user, and then have them be in your cache for months and months and months at a time and take up the entire disk space of your user's phone. So clean your caches. You can do that with that v1 to completely dump old versions of the cache, or many different ways. So lastly, push notifications. They're very, very powerful. They're also still a little bit more complicated. Basically, what you have to do is subscribe your app, your instance of the app, to a push manager, which is your server running a notification push mechanism. This is done right here, and it basically, using the server's public key, subscribes this browser to push notifications. The user visible only true is a required flag that basically you as a developer saying, I promise to always show a notification when a push event occurs. And you put the key in, and if your registration succeeds, you get a subscription back. You want to save that to your own server, and with that subscription, you can target this particular user's browser and send push notifications there. Then in your service worker, you can listen for the push event. This push event basically fires whenever your server sends a push notification to this device using that registration we saw before. It can have all sorts of different options for your notification. And eventually you call the show notification as you promised with title and a bunch of options. And that generates the actual push notification you see either on desktop or on mobile. Finally, you can also respond to clicks on the notification. So you can enrich the notification with actions, but the default action you have is clicking on the notification. Whenever that happens, you can close the notification so it doesn't stay on your user screen all the time. And you can open a new window of your awesome app, for example, in the notification screen. You can also respond on the data inside the push notification to customize this URL. So this is the super quick way to do push notifications on the client side. You obviously need a server capable of sending these push notifications. You can build one yourself fairly easily with Express, for example. And if you want to go for a managed solution, stuff like Firebase has great tools for this. So things to remember for push notifications are push notifications need to be timely, relevant, and actionable. These three are the three golden standards of should I send a push notification. So it needs to be timely, so you don't want to send out a news message of news that happened a year ago, obviously, because you want push notifications of what's happening right now. It also needs to be relevant. If your user doesn't have to have anything to do with this, for example, if they're not even remotely close to an event that's happening, it might not be relevant for them to actually show you the notification. Lastly, push notifications need to be actionable. This means that you actually have to be able to do something with it. Just notifying someone with a push notification is very intrusive, so make sure that they can either follow up with something or don't show the notification at all. Again, be a responsible developer. So I have some useful links here. The Google documentation has a lot of information about progressive web apps, a lot of examples, and things to get you started. They also have a separate code lab on push notifications if you want to try that out. They have a code base fully set up for you to be able to start working on your first push notification, start playing around with it. Again, I mentioned it before, serviceworkers.com if you want to learn the life cycle of service workers. It's a really awesome game to get to know this information. And if you have any questions about any of the PWA stuff, you can always send me a tweet. So thank you.